This tutorial is going to cover Boolean logic. Before we begin, make sure that you have Java and the Java JDK downloaded on your computer. You can check by running java-version in your terminal, and also make sure that you have IntelliJ downloaded on your computer. It's suggested that you watch the previous Java tutorials that are in this Lunch and Learn playlist. As a reminder, a Boolean is a primitive that has a value of either true or false. Some vocab. A Boolean expression is a statement that evaluates to a Boolean. For example, true 2 is less than 3. And normally this expression would be more complicated with more parts to it. And a bang, denoted by an exclamation point, indicates negation. It turns true into false and false into true. And this would be used whenever you are trying to check for something, mostly if you're trying to check for a negative case, like checking to see if something is not equal to something else, or checking to see if something is not null. Comparing numbers. Double equals. So two equal signs together is what you use to check for equals, and it returns true if the two numbers or expressions are equal. Exclamation point followed by an equal sign is not equal, and it returns true if two numbers or expressions are not equal. A less than symbol is for less than, and it returns true if the left is less than the right. A less than symbol followed by a less than symbol followed by an equal symbol is less than or equal to, and it returns true if the left is less than or equal to the right. A greater than symbol is greater than, and it returns true if the left is greater than the right. A greater than symbol followed by an equal symbol is greater than or equal to, and it returns true if the left is greater than or equal to the right. So single equals versus double equals. A single equal sign is used for assigning values to variables, while a double equal sign is used for comparing two values, variables, or expressions. If you try to use a single equals in a Boolean expression, it will always return true. So mixing these two things up can have major consequences in your code. Comparing objects, like strings. Comparing objects, like strings, cannot be compared in the same way that numbers are. They must be compared using either object1.equals object2 to check for equality, or object1.compare2 object2 when checking for relative bigness. If you try to compare objects in the same way that numbers are, you would actually be comparing the memory addresses of the objects, which is not usually what you want to do. The .compare2 method. .compare2 returns a number. This number is basically reflective of taking the object the method is being called on and subtracting the object passed as a parameter from it. So the return value is positive if the object being called on is bigger, negative if it is smaller, and 0 if it is equal to the object being passed as a parameter. Expressions with multiple parts. Sometimes Boolean expression need multiple parts. Like if you want to have a Boolean for a number being negative and even, or if you want a Boolean for a number being even or a multiple of 5. So two ampersands next to each other, when put between two or more Boolean expressions, require both expressions or all of the expressions to be true in order for the whole expression to be true. And double pipe, when put between two or more Boolean expressions, are there to require at least one to be true in order for the whole expression to be true. So this symbol isn't a lowercase l, it's the symbol above the backslash on your keyboard. Operator precedence. So the double ampersand has precedence over the double pipe, so any and parts of a Boolean expression will be evaluated first, but it's common practice to put a lot of parentheses in a Boolean expression just to be extremely clear about what's being evaluated first within the expression. This will keep the person who comes along after you from being confused about what exactly the return value would be, and it'll keep you from getting confused. So, evaluation of multi-part expressions. Multi-part expressions are evaluated from left to right only as far as it takes to get the final answer. So if an expression with an and in it will stop being evaluated as soon as something evaluates to false, and an expression with an or in it will stop being evaluated as soon as something evaluates to true. This is helpful to keep in mind as you build up more complicated Boolean expressions. So let's say, for instance, you wanted to call a function, you wanted to check a function on a string, but you weren't sure if that string was equal to null or not. You could, within the same Boolean expression, you could say string not equal to null and the string variable dot some other method. And normally calling a dot method on a null variable would give you a runtime error, right? A null pointer. But in this case it wouldn't, because if that string is null, it would stop evaluating the expression and before it got to the dot call on that null variable. De Morgan's law. So De Morgan's law is a set of rules used to negate Boolean expressions. And these next two lines are it. So it says not quantity A and B is the same as not A or not B. So it flips this center operation and puts a bang with each variable on either side. And then not quantity A or B is equal to not A and not B. So really, it's the same as the one above it, just in the opposite direction. It changed an or to an and then put a bang with each variable on either side of the operator. Something to keep in mind as you're building up more complicated expressions. You'll just be able to if you keep this in mind, it'll make it easier to get the complicated things correct. So we're going to do a Boolean logic walkthrough now. Let me pull up my IntelliJ. Presents. Okay, so I want to make a new package called Boolean Logic, and then a new Java class called Boolean Logic Walkthrough. Double click to make the left pane go away. Public static void main string args. Okay, so first I want to write a method that returns if a given whole number is even. So public static boolean is even, and then it's a whole number, so it should be an integer. Int num. So, in order to, and again, this gives me an error. It's missing a return statement, so return. So now I need my statement. So to check for evenness, I know that if a number mod 2 is equal to 0, it's always even. So I'm going to say return none mod 2 equals 0. So any operation on numbers like this, any arithmetic operation, has a higher precedent than these evaluations. So I know that this will happen first. But if you are not comfortable with that, you can always put in parentheses just to be completely sure. Okay, so the next method is a method to return if a single given letter is uppercase. So here I have public static Boolean is uppercase. And it says single letter, which means it'll always be a single letter, which means I can use character, letter. Okay, so in order to check if it's uppercase, I need to know if it is between A and Z, the uppercase versions. And luckily for us, in the ASCII values, all the uppercase letters are next to each other. So it goes uppercase A, uppercase B, uppercase C, all the way through uppercase Z. So what I can do is check that letter is greater than or equal to uppercase A, and letter is less than or equal to uppercase Z. And that's it. That's how I tell if it's an uppercase letter. So the next one is a method that returns if a given letter is a vowel. So public static boolean is vowel. And it's just a letter again, so I'm going to do char letter. Give it a return. So this one is checking to see if it's A, B, if it's A, E, I, O, or U. And I'm going to forget about Y because it's only sometimes Y. So the first thing I want to do is make this letter lowercase, right? So since we don't have if statements yet, and there's no way for me to check to see if it's already lowercase, I am going to just check for the uppercase and lowercase versions of this letter. That'll be the simplest thing. We'll just go with that. So I want to say return letter is equal to A, or letter is equal to E, or letter is equal to I, letter equal A, E, I, O, or letter is equal to U, or letter is equal to A, letter is equal to E, A, E, I, letter is equal to O, or letter is equal to U. So that checks to see it'll return true if it's any of those letters. So the next part is to write a second version of this method using De Morgan's. So I'm going to do public static boolean is vowel De Morgan's char letter. Okay. So this would be the normal thing that I had, right? But I want to do De Morgan's. And that means that I'm going to put a bang on the outside, right? And remember before what that did is it flipped all of these connectors, so all of these ors become ands. And I'm getting a warning here that everything after this will always be false. So it's something to keep an eye on whenever you get warnings like this. It means that this whole thing will never ever be able to evaluate to true. So keep an eye on these types of warnings so you know exactly what's happening with your code. And okay, so I have all these ands, right? But I forgot I need the second part of De Morgan's, which is to negate everything else. Not. Okay, so what this will do is this returns true if it's not any of those letters, and then the bang will negate that and make it false. And it returns false if it is any of those letters, and this bang will make it return true in that case, which is checking to see if it's a vowel. And the next one is a method that returns if a non-whole number is between 100 and 200. So public static Boolean is between 100 and 200. Double num, since it's a non-whole number. And I can just return num greater than or equal to 100 and num less than or equal to 200. So it doesn't specify here if this is an inclusive or exclusive between, and I just assumed inclusive, which is why I put these greater than or equal to. If you assume that it's an exclusive, meaning that 100 and 200 shouldn't be there, then we would take off. Okay. So this last method is a method that returns if a given string starts and ends with the same letter. So public static Boolean beginning, or let's see, start matches and string word. Okay. So we're going to do that. String start is word.substring 0, 1. String end is word.substring word.length -1, which is the last index, since we know that strings are 0 indexed. We're going to return start.equals end. Okay, and that'll return that. So now what we should do is call all of these with a true, once where we know it will return true, and once where we know it will return false. So we're going to call isEven for isEven equals isEven for Boolean 87 isEven equals isEven 87. Boolean is uppercase. True equals is uppercase. And then this one, I'm going to use a. Boolean is uppercase false. And this one I'm going to use G. And as you've probably noticed, all of these method names start with the word is, And that's the common convention for methods that return Boolean, is to put the word is the front, so you can tell that what they're going to be returning is a Boolean, and it's going to be checking some value. So Boolean E is vowel equals is vowel E. Boolean H is vowel H. Boolean O is vowel De Morgan's with an O. And Boolean T is vowel is vowel De Morgan's capital T. And then between 100 and 200, Boolean 34, 134, 134, Boolean 56, and then start matches end, Boolean stars matches, Boolean waterfall matches, Oops, that's what I meant waterfall. Okay, so now I have all of these, and I'm just going to go through and add in the print statements for them. And so now it should be true, false, true, false, true, false, all the way down. System.out.println. Copy that. H is vowel. O is vowel. T is vowel. Okay, so now, like before, I want to do run and then run. And I'm going to choose Boolean Logic walkthrough. It's running. Ooh, an error. Oh, I forgot my ending parentheses. Okay, I'm going to press the green arrow to run it again. And see, we got it. True, false, true, false, true, false, true, false, true, false, true, false. Nice. Okay. So we probably want to add labels for all of these so that it makes more sense. So I'm going to go ahead and do that now. So I'm going to say is even with 4. Is even with 87. Is uppercase with A. is uppercase with G. And remember again, I need that plus in order to make the variable append correctly with the string. Is vowel with E. Is vowel with H. Oops. Is vowel with De Morgan's with O. Is vowel with Morgan's with T. Oops. With 134. Oops. With 56. With stars. I keep hitting B. With waterfall. Plus. Now I'm going to rerun by hitting the blue triangle. Or sorry, green triangle. And now I have this, which makes more sense. So now I have these labels. And to make it really make sense, I'm going to go through and put a new line character at the start of every grouping so I can really tell the different groupings apart. Green triangle. And there we go. So that is the completion of this practice that we've been walking through. And I hope that that helped make sense of Booleans and how they work. So I'm going to X out that. Back to my Boolean walk, my slideshow. Okay, so the practice for later is to write a program with the following methods. A method that returns if a given string contains a given letter. A method that returns if a given whole number is odd. A method that returns if a given non-whole number would round up. A method that returns if a given whole number is a common multiple of 2 and 3. A method that returns if a given string contains without more than one word. And a word in this case is distinct parts of the string that are separated by spaces. And a method that returns if a given whole number has a 4 in the 100th place. And then what you should do is call each method at least twice from your main method to make sure they work. You should call it once when they should return true, and once when they should return false. And then print the results from the method calls with the appropriate labels. So basically do what we just did with our walkthrough. And that's the end. I hope that was helpful.